Hey folks, hope you're all having a great day. I'm Premkumar, Thangamani, a technical evangelist at Yugabyte. Welcome to the 105th episode of YFTT, Tech Talks for Engineers by Engineers. Today, Brett will be showing how to build an autonomous AI agent on top of YugabyteDB. Brett Hoyer is one of our specialists here at Yugabyte, focused on developing cutting-edge applications on top of YugabyteDB. So, Brett Hoyer for you folks. Over to you, Brett.
Thank you, Prem. Yeah, as Prem mentioned, I'm on the developer relations team here at Yugabyte, working in the database ecosystem, seeing what tools integrate well with Yugabyte, as well as building applications to showcase the functionality of the database. So today we're going to be working with autonomous AI agents and building an AI booking recommendation service on top of YugabyteDB. So let's get right into it. So first, before we dive into a demo, and I want to leave plenty of time for a demo rather than just speaking to everyone, I just want to do a little bit of level setting and explain some of the terms that we often hear in the AI ecosystem. So we're all using AI tools nowadays, or I would say most of us are at least familiar with OpenAI and maybe GitHub Copilot, Google Bard, a number of other things. But at its core, an LLM is something that is trained on a large amount of text or data and returns text. So now LLMs are multimodal. You can speak to an LLM and it can ingest that, and it can also create images and videos. And there are a number of different multimodalities coming up in the AI ecosystem. But today we're mostly going to be speaking about an AI being trained on a large amount of data and returning text based on that data. So this is done, creating an LLM is done by pre-training and fine-tuning. Pre-training is what's known as the process of ingesting a large amount of data into a neural net. And
Brett, could you
something wrong?
Something looks like Braun is saying that there is an echo going on. Do you hear an echo? Hey, Braun, is this good right now?
Sorry, I don't hear an echo right now.
Braun is hearing an echo. Is there do you have your YouTube open by any chance? Maybe just
no,
me.
I don't.
All right, let's move on. Sorry about that. Yeah.
So training is the process of ingesting a large amount of data and putting that into a neural network to create a base model. So a base model takes quite a bit of time to be generated. It can take many weeks and cost tens or even hundreds of millions of dollars if done at the scale that an OpenAI is generating a base model. Whereas fine-tuning is passing, question and answers to this base model in order to make sense of it and fine-tune it so that we can actually create what we know as, an LLM, which is a question and answering or a prompt answering program. And this can take as little as one day and is done by humans or other AI tools that help this process. Retrieval augmented generation applications are applications that can take in various data sources and synthesize that information to provide a response. So one example of that would be an application that I built that used YugabyteDB as a data source, as well as Wikipedia documents. And I was able to put a bunch of financial information for S&P 500 companies in YugabyteDB and a bunch of Wikipedia pages for each of these companies into a vector store on my machine. And I was able to ask questions and search from both data sources. So we're not beholden to searching just from the knowledge base from which the model was trained, but also our own data sources such as Slack, PDF documents, the list goes on and on. So there are a couple AI frameworks that I've worked with, namely LangChain and Llama Index. These are two of the industry leaders for building applications on AI. Today we'll be using LangChain. Llama Index in particular is very good at RAG applications. So if that is something that is of interest to you, I would check out Llama Index. And then today, of course, we'll be building an AI agent, which is able to act autonomously if given a set of instructions about the environment in which the agent acts and given a few tools. We'll be showing what tools are in a little bit. The agent is actually able to perform actions on our behalf rather than just answering questions from prompts. Really quickly now, vector embeddings are an aspect of AI that are important, especially when talking about vector databases and, of course, using YugabyteDB as a vector database in a sense. So vector embeddings are the numerical representation of data. So for instance, you might be typing a prompt, you might be typing the cat in the hat, and the cat in the hat gets converted into an array of a certain number of dimensions of numbers. And this number of dimensions varies from model to model, whatever AI model you're using to get these embeddings. The OpenAI model that I've used in this application to get embeddings is, I believe, 1,536 in length. So it's quite a lot of data. It's a lot of storage. And vector databases such as Pinecone are particularly good at searching on these vectors. But as we'll demonstrate, pgvector is an extension in the Postgres ecosystem that can be used with YugabyteDB and other Postgres compatible databases to do a similarity search on text. And then this is just a sort of abstract image that I asked ChatGPT's DALL-E to generate an image showing how text is converted to vector embeddings.
Could you go back to one slide, back to the previous slide? So I just want to say one thing. The vector slide. So so basically, a vector is basically a list of numbers, an array of numbers, and embeddings come from the terms of machine learning. But pgvector does not provide you embeddings, so it provides you features or functionality to manipulate vectors, which are essentially an array of numbers. It would be your responsibility to create the embeddings for your data set, and then use pgvector for, like for example, distance or similarity between two vectors. So that's it.
Exactly. Yeah. So you would be generating embeddings for the input, but you will already be storing embeddings for each of the things that you would like to search upon in your database in a particular column that holds those embeddings. So thank you for that clarification. So showing how these vector embeddings are placed in YugabyteDB, we're using the pgvector extension that gets created on the database. And a column is created on a database table specifying the number of dimensions of the vector. So as I said, the OpenAI model that I'm using to generate embeddings returns 1,536 dimensions. So that is specified in the particular column. And when inserting a record, this vector, is just a very long array of numbers across all these dimensions. Apologies. So when searching, like Prem was just mentioning, you are using features of pgvector to do this search. So I'm searching all of my listings in the Airbnb listings table and ordering using cosine distance on a search input that was vectorized. So that is how this works. And there are multiple ways of doing similarity search. There are other features of pgvector that you can look into. So now that we've gone through some of the basics, hopefully quickly enough, I'd like to just get right into the demo. Before immediately going into the demo on the booking accommodations AI system, I just wanted to show very, very quickly what an AI agent allows us to do to begin with. Sometimes it can be too complicated, seeing a lot of code all at one time. I want to show just how truly simple an AI agent is to start developing with just a little bit of information. So our end goal here is to create a booking agent that can search listings in my YugabyteDB database. It can make bookings. It can cancel bookings. And this application is built on LangChain, OpenAI, pgvector, and YugabyteDB. It's worth noting that LangChain is available in a variety of programming languages, but I'm going to be using Python for our demonstration today. So let's get right into it. I don't want to waste any time here. Let's see. Got that. So on my right, obviously, is my terminal. This is a terminal application. I'm going to be developing a UI for questioning and answering soon, but this is just an application that I've developed over the past week or so. So first, I'm just going to show the absolute basics before getting into the full extent of the application that I have developed. So this script that I'm about to execute imports some environment variables for interacting with the LLM, like API keys and such. And I'm importing a library from LangChain to use OpenAI, essentially. And I'm instantiating an LLM chat agent here, and I'm going to ask it a question. So it's prompting me for a question. I'm going to ask it, what is the weather in San Francisco today? So predictably, the agent is going to respond telling me that it doesn't know anything about the weather of San Francisco today, because the agent is, or excuse me, not the agent, the LLM is trained on a data set at a particular point in time. You might have used ChatGPT before and noticed that it gives you a response that its knowledge base is finite. It's only up to January of 2023 or something like that. So this model doesn't have access to the internet. It can't access up-to-date information. So by creating an agent that has additional tools that can interact with the internet, we can augment our application. So I'm going to show now how to quickly instantiate an OpenAI agent in, excuse me, this needs to be commented out, in LangChain. So I'm using this Tavily search results tool. A tool can be thought of just as like a function with a little bit of extra flavor to it, a little bit of extra metadata that allows the agent and the LLM to know a little bit more contextual information about the tool. So the Tavily search results tool, Tavily is a search engine that is optimized for use in AI applications. And I'm pulling down a prompt. This is just a boilerplate prompt that can be passed to the LLM for telling it to answer my questions, essentially. And this agent that is instantiated, the OpenAI tools agent, gets passed to an agent executor. The agent executor is what is used to invoke, inputs to it. You can store the intermediate results of everything that it has been processing, as well as the chat history. But for the time being, I'm just going to output this in verbose mode to show you how this will work. So by asking it the exact same question, we can see that it is going to access that tool that we've provided to the agent in order to answer that today it is 48 degrees and high humidity in San Francisco, which I can verify because that is where I reside. So just by providing a little bit of additional functionality to the LLM by way of this tool, we're able to provide more informed and up-to-date information to the user. So this is just a very, very simple example. Now I want to dive into the demonstration of how we can actually add additional functionality in the way of tools to actually create a booking agent. Finding the weather is cool and all, but we actually want this autonomous agent to be able to execute things on our behalf. So let's walk through how that is going to be possible. We're going to be importing a few additional classes in the way of messages and prompt templates. So we're going to actually take a little bit more control over what is passed into our agent. And we are still going to be using Tavili search results if we would like, but we're not bringing in too much more than we did on the other side, just information about connecting to our database and how things should be structured. So I will walk through everything now. I've defined some functions for getting listings, creating bookings, etc., all of the functionality that we are looking for from this application. And these functions actually, rather than connecting to the database directly through the LLM, I've opted to create an API layer in Flask that can do the database operations for us. So the LLM is just going to be responsible for passing the proper query parameters to these endpoints, and the database will be interacted with from that Flask API. And I've decided to do this for multiple reasons. The first of which is that LLMs are very good at creating SQL queries, but they're not 100% accurate all the time. And I wanted to take a little bit more control over how that is executed. Also, I didn't want to be passing huge arrays of vector embeddings through the LLM because the context window for the LLM is finite. It can only store so much information. So I wanted to off-source that to another service. So as we can see, this function is going to execute an API call to this API that I've created here that can ingest the filters and the embeddings and generate a query for us. And in doing so, it'll allow the agent to execute things on our behalf. These functions are essentially tools, as I mentioned, but I'm adding a little bit of extra information. So a structured tool class.
Brett, I'm going to interrupt you here. So we have 10 minutes more. So
yeah.
Could we actually show the demo first, and then we can explain the code?
We can. I'm like a moment from getting to the demo.
Okay, yeah. Thanks.
So these tools here are created from the functions that I've created. As we can see here, it's taking in the function. Actually, none of this information is even necessary when creating a tool. It's just helpful for the LLM and the agent to choose which tool to use in which use case based on the description that you have provided it. And you can provide different arguments that will be, you can provide the schema for this. So just the same that we saw in the pared down demo that I showed previously, we're passing tools for each of these particular needs that we have of this agent. And then we are passing a more interesting prompt. Before we had just passed the default prompt that we pulled down from the LangChain hub. Now I'm actually providing all sort of context to the AI, telling it that it's a friendly travel agent, telling it how to structure different parameters that I want to be passed to my different tools, different neighborhoods that it can act upon, this, that, and the other thing. I'm not claiming this to be, a pro-level instruction that is necessarily given to the AI. As I said, this is just what I've worked on this week, and it seems to be working relatively well, but we will see. And everything else is much the same that we've seen. I'm storing the intermediary steps here and passing the chat history to my agent executor so it can keep some history to inform its future decisions that it makes. So as you mentioned, we're short on time here, so let's get into this demo. I need to start my API layer as well. And we have our database running locally in Docker, our YugabyteDB database. So my agent here, much the same as before, is asking how it can help me. So I'm going to ask it, what neighborhoods in San Francisco have the best weather? So here it is going to respond telling me that the Mission District has the best weather in San Francisco. So what we're seeing here is the agent actually hasn't interacted with our database or any of these functions that we've just shown. It's interacting with Tavili to search the web to find the neighborhood with the best weather. And now I can ask the agent, great, find me some private bedrooms in San Francisco, or excuse me, in the Mission District. So here I've chosen to print this out just for our edification, but we're seeing that it is passing these query parameters to the backend such that it can create a query and search for listings in our database. So if we go over here, we can see that a large vector embedding has been created and a query was formatted as well, searching for listings in the Mission District. So here it's returned, it's synthesized these results, and I'm able to actually say, please book the second you found. And this booking was automatically generated, no human intervention, no use of a user interface or anything. Just through this chat conversation, this booking was made in our database. And we can verify this by asking the agent to show our bookings. So I have quite a number of bookings. Let's see, what was the one that I just asked it to create? Let's see if it worked properly. A secluded leafy haven in the heart of the Mission. So this is the one that we have just booked. So let's say that we are, we changed our mind and we want to cancel that booking. We can ask the agent, just the same as we had before, cancel the third booking.
That's a lot of bookings. Looks like you travel a lot.
I know, it's a little bit obnoxious here. And of course, it's a little bit naive. I'm planning on adding additional functionality to like add dates and stuff like that. This is a little bit of an example, but you get the point here. And now the booking was in fact deleted, or at least I hope that it was. Let's see if I show me my bookings. Don't shoot me if I'm wrong here. We will see. Yeah, so now we can see that we only have 11 bookings where we previously had 12. So we can see how the agent is able to act on our behalf. I would say something of interest that I kind of rushed through the code because we were short on time, but I wanted to show that by telling the agent, so we're storing the chat history, but we're also returning intermediate steps from the agent executor. And what is interesting about...
I have a question. So at what point in this code execution is the data from the database transferred to the LLM?
So when the functions are executed here, so for instance, when you are getting listings, the LLM will get a request in the form of a prompt saying, get me listings in the Mission District of San Francisco. It will send this API call. And just like any other application that we're developing, it will get the data back and it'll return the data. So by returning the data, that returns the data back to the LLM to synthesize, and then subsequently we can add all of this information to the chat history to use it in subsequent requests to the agent. So, this could have been developed in a totally different way, which is something that I want to get across. Like, you could have connected to the database directly through this function. There are even SQL database tools that are native to the LangChain ecosystem that you can look into. I've just found that they're not quite there. They're not, but I bet a month from now they will be. The way that things are so rapidly moving in the AI ecosystem, these tools will be totally different in the very near future.
So I have one more question. If I understand right, you used OpenAI for this project, right? So
Yep.
will LangChain work with Anthropic's Claude or Google's Bard?
Yes, so LangChain does work with other LLMs. In this case, the agent that we're extending or building on top of is the OpenAI tools agent. So I'm not certain if at the moment, this particular agent can take in an open source agent, but you can, an open source model. But there are ways of creating your own agents that can certainly take in, open source models.
Okay.
That is for sure.
My last question, because no one else has been asking questions, is basically some enterprises might feel very wary about sending their data to an external LLM. So will, for example, Claude or Bard or GPT or all data are processed by an external service. So if you decide to host your own LLM, like for example, Mistral from Hugging Face, will it work? So that you don't have to send.
You can certainly use LangChain with Hugging Face models that you've found. I've also used local AI is another way of using Hugging Face models to run them locally or in the cloud on your own. That's something as well to look into.
Right.
Yeah, that is
end of time. It's almost 10. We'll do a hard stop here. So thanks a lot, Brett. It has been phenomenal. This is an amazing. I've always been a big fan of AI. I thought it was just a research project, but since ChatGPT came out, things have changed. So Brett has written a lot of tutorials on how to do more of using this AI. It's on our doc site. You can check it out. Brett, your closing comments.
Nothing. No, I appreciate it. I think, we're merely scratching the surface in terms of application development on top of AI. I'm sure in a couple of months I can present something totally different and equally or more interesting in this space. So I look forward to doing another tech talk on a Friday, maybe in a few months.
Awesome. Yeah, we're always looking for speakers and topics.
All right. Well,
Okay, thank you, folks. Please reach out to us on public Slack if you have any further questions.